Hi, welcome back to the channel. So in this video, I want to talk about kind of a very neat approach to having Pydantic models that don't fully validate their data, but that still will be essentially initialized as the Pydantic model, as well as giving you the errors. So this was actually a question that a student asked in my Pydantic class on Udemy. And specifically, this is what he wanted. He said, I wish to ingest JSON API data that sometimes will fail validation for whatever reason. So in other words, allowing mistakes or allowing missing data or bad data on the incoming side. And instead of effectively throwing that response away, because with a regular Pydantic model, if it doesn't pass the validation, you don't get a Pydantic model instance back. It just gives you, a validation error. So it said, I want the model to still be instantiated with just the fields that pass validation. So in other words, a partially validated model, but with the missing or failed validation fields set to some special sentinel value or perhaps none. And in this case, that's what it will be. It will be none. And then he said, my intention here is to insert this into Postgres and have an errors JSON column or JSON binary column, which contains the validation error JSON that's going to contain information about what went wrong. How can I achieve this? Now, my immediate reaction was no, this is unlikely because Pydantic v2 doesn't support this natively. v1 kind of did in some fashion, but v2 kind of dropped that. And I couldn't see a way of getting around taking over, all of the validation to achieve something like this, which essentially negated the built-in validation usefulness of Pydantic. So I could see a way of doing it, but essentially not using any of Pydantic's validation steps. So fortunately, the person who read my response was undeterred, and he continued working on the problem and eventually came up with a really neat solution to this. And I really wanted to present here what that solution is. So there's a link to the repo. So basically the code is not mine. This is somebody else's code. And we're just going to go through it and see, what his approach was. And this is also the first real practical use I have seen for wrap validators in Pydantic. So it's a really good example of how those work and where they can actually be useful. I'm sure there are other uses for wrap validators as well. I've just never actually encountered a situation where I needed a wrap validator. And this, however, is a particular situation where you actually do need it, where it actually comes in very useful. And it also will show you here how model validators can be used as well. All right, so let's go through this step by step. And the first thing is we're going to need to do a few imports. So again, the code that I have for this video is in my Git repo, which is linked below. And basically, I'm just going to take the code that is in this repo over here, but just walk through it step by step. So we need to do some imports. So a lot of them are Pydantic imports. We do need to import annotations from future, and this is because we're going to use a type hint in a class that in a class method that actually specifies the class itself as a return value. In order to do that, and for the linters to understand that, as well as the editors to understand that, you need to import annotations from future. Now, with Python 3.12 and above, you actually don't need to do that. There is a self type hint that's available in Python 3.12, but this is backward compatible, with earlier versions of Python as well. So we'll stick to that. That's what the author of this code used, so I will use it here as well. And I do have a link in my repo in the notebook that will link you to the documentation about this self type hint. Now, since the idea is to include some attribute on the Pydantic model that will contain the validation errors, right? We want to have not just the fields that validated OK, but we also want to know which ones didn't. So we're going to need a structure for validation errors, for these custom errors. These are not Pydantic validation errors. It's just going to be a way of us representing these errors. So he used a class, and he used a Pydantic model for that. So this is actually a Pydantic model. It's going to have the field, the type, the message, and the input. And that's what we're going to use to identify, fields that failed validation. And a lot of those values will actually come back from the Pydantic validators themselves, hence why the fields are named this way. Now we'll want to identify an invalid field somehow. Now using none is not really an option because none could be an actual valid field value for some fields in the model. So using none is going to make it very hard to distinguish between, well, this field was none and that's okay, versus this field is none but it's not okay. So instead of using none as a kind of a value placeholder to indicate that a particular field in the model is bad, we're going to use an arbitrary object, and that's called a sentinel value. And very often in Python, when we want to define a sentinel value, we just basically create an object. So this is going to essentially give us a way of assigning an invalid value to a field. And then it will get cleaned up later. But as we progress, as we do the validations, we're going to use that to indicate temporarily that a field has a bad value. Okay, so now we can get to the actual implementation. So it is done by defining a new Pydantic base model that can be used then, for your own models. You'll inherit from this new base model that's going to allow you to have these exceptions and these partially validated fields. So we start with a Pydantic model, and the author called it missing or invalid as none. That's just the name he chose. I'll keep that as well here. And then there's a private variables. You can have private variables in Pydantic, and it's going to be called underscore errors. And it's basically just going to be a list of these errors, right? As the validation fails on certain fields, we'll add the errors to that list. So that's pretty straightforward. There are now two cases we need to distinguish for invalid fields. One case is that the field is required but is missing from the data that you're deserializing, or the field is present in the data that you're deserializing, but it actually fails for the validation. Like maybe, you were requiring a Boolean and you're getting, an array back or a float back or whatever it is. So to identify missing fields, we're going to use a model validator. Model validators in Pydantic give you a way to access all the fields in the instance and perform some validation that now can reference any of the fields in the model. And just like with field validators, where you have before or after validators, the same thing holds true for model validators. You can have before and after model validators as well. So the author is using the before model validator to identify all the fields that are required in the model but not present in the data that is being deserialized. So again, I have a link to the Pydantic documentation for model validators in the notebook. So let's take a look at that code and let's see what it's doing. So the model validator has a mode of before, and the function name is called missing fields as sentinels. The idea is to identify all the missing fields in the data that's being deserialized and add them back in, add those required fields back into that data dictionary and set the value of that field to that sentinel value. Not none, because we need to know that this was a missing field. This was a field that failed validation. Okay, so we're going to set it to that sentinel value. And this will differentiate it from other fields that are nullable that may be none, right, in this data dictionary. So model validators will receive the data, and it should be a dictionary. It's not in all cases. And for these examples, though, for this particular use case, it will be a data dictionary, but still we guard against that. And if it's not a data dictionary, just return it as is. Don't try and do anything with it. There is a link in the GitHub repo in the Jupyter Notebook that tells you about model validators in Pydantic. Go ahead, click on that, take a look at when this can actually happen. So what's happening here, right? Well, data is going to be a dictionary, and then we're doing a union with a dictionary comprehension. What is that thing doing? Well, basically, this is a dictionary comprehension that loops through all the model fields, right? We're doing this loop here, and we're taking the model fields, which is a dictionary, which has the key is the field name, and the value is the field info, right, that we have from the Pydantic model. So we're going to loop through all of those, but we're going to restrict them. We're going to apply a filter in the comprehension where we want to only look at fields that are required fields, so not nullable fields. And furthermore, we only want those fields where that field name is not in the data dictionary. It's not in the data that we're deserializing. In other words, it's a missing field. And so we create a new dictionary that has the field name and the sentinel value, and we essentially add that into the original data dictionary, right, that we're getting at in the before model validator. So we perform that union of those two dictionaries. Okay, so that was step number one, is identifying missing fields. Now the next step is to create a field validator, and we'll apply that to every field in the model. But what we want here is to inject this validator without losing the rest of the models and Pydantic's validation logic. And this is where the wrap validator comes into play. We can essentially insert ourselves into the validation flow and set the failing fields to an instance of that error class that was created earlier. Remember, we were going to use that to identify and document essentially the errors. And then later we'll do another validator, which is going to be an after model validator that will handle those fields that are set to those error instances. But for now, let's just take it one step at a time. We just want to replace any field that is missing or fails validation with our custom error instance. Now we know which fields are missing. They're set to that sentinel value. And then we're going to then look at the fields that fail validation, and when they do, we're going to set them to an instance of that error model. So let's go ahead and do that. So basically we're adding now another piece of code here. So let's add that in. And here is our field validator. And it applies to every field. That's what the star is for. And the mode is wrap. It's a wrap validator. So a wrap validator is going to receive the value, right, that it's trying to validate. It's also going to receive the handler, which is going to be essentially a pointer to the next validation function that needs to run. And we're also going to get some information, some validation info. So this is the standard kind of signature when you have a wrap validator in Pydantic. So what is this doing? Well, it's going to run for every field. So we get the value, and if the value is a sentinel value, then we know that this was a missing field. So we're going to, instead of returning a value or a new value or raising an exception, we're just going to return an instance of this error class, of this error model. And we're going to give it this information. The field info is the field name. Or the field in here, the field name is the info field name, right, that we get from this argument that was passed in. Otherwise, this was a field that wasn't missing, so we have a value for that field, and normally we would, call the next step, let's say, in the validation routine. With a wrap validator, you get a handle to what that next step is. Well, we're going to call it, but we're not just going to call it and just let Pydantic then raise potentially a validation exception. We're going to catch that. So we're going to put a try, and then we're going to catch any validation errors. So this wrap validator essentially is inserting itself in the Pydantic validation flow. This here calls the next steps. It's going to go through the remainder of the validations that we have, either the built-in validations or additional field validators if we have them, but it's going to go through those. And if there is a validation exception, we're going to trap it here. And instead of letting just the validation error bubble up and then, the person's code, your code that's trying to deserialize, that's going to, try and load this data, instead of it stopping with a validation error, it's going to continue because we are silencing this validation error. And instead what we're doing is we're setting the field value now to this error object, where we specify the field as the field name. And then this validation error has some values in the errors. And this corresponds to this type message and input. So we get that from the errors, and we take the first element in the errors, and then we expand that basically so that we get named arguments that would get passed to the error Pydantic model. So at this point, what do we have? Well, we have a valid Pydantic object. We've actually suppressed validation errors, and instead of having a validation error exception, we now have a Pydantic model instance, but some of the fields are going to have that error value. So let's actually try it out and see what's happening. So again, I'm just going to copy paste the code from my notebook. So here's a model. And we are now inheriting from missing or invalid as none, which is that kind of specialized partial validation thing. And we specify 4 fields. A should be an int, it's not nullable, B a bool, etc., and then not nullable. Now here's the JSON data. So we've got a lot of problems with it, right? We have, let's say, D is missing. We have C is null, but that should be a string. It shouldn't be nullable, right? Then B is a string here, but it should be a Boolean. That's a problem too. So normally, if you had, if you were inheriting from base model, so let's do base model like so, and we try and do this model validate, then we get a validation error. We get these validation errors, right? All 3 of those. So instead, now we're going to inherit from missing or invalid as none. Need to execute that. So when we run this, you'll see that we do not have an exception anymore. And we can inspect the fields. We can say for field in M, and then let's just go ahead and print the field. And then I'll print 2 blank lines between each field, just so we can see what's going on. So you can see that we have field A has value 3. But look at field B. It now has this error. And it says input should be a valid Boolean. Unable to interpret input. The input was something. That's what's coming back from that validation error exception, right? That we trapped over here. And then we get the same thing for C. Input should be a valid string. And then for D, you'll see that it's a little bit different. It just says the field is required. And that was the required field D, which was missing from here. Remember, that essentially got caught and set in the model validation. We had the sentinel, right? So in the model validation, we essentially caught that D wasn't in the data. We set it to a sentinel. And then in the field validator, it was a sentinel here. And so we set the error just to that. And the default for that error is a missing for the type and field required for the message. That's where those values over here are coming from, right? So now we're almost there. In the final step, we want to replace those error values with some other default. Now in this case, the author wanted to write these values out to a database, and I'm assuming that those fields were nullable in the database. So he wants to return null for those values. But you could really, decide what you want to return when you have a failed validation, either missing or just, failing the the other validations in the model. And so for that, we're going to essentially take the same code as before. So let me go ahead and copy this, paste it. And then we're going to want to replace those errors. So we want to do two things now. One is we want to replace those error values with a none value, and we want to populate that errors list. Remember that errors, that private field that we had, that private variable? We want to put those errors into that list. So we're going to use a model validator, but this time it's going to be an after model validator. We want to do this after all these validation steps have happened. We can now essentially loop through all the fields, and if they are instances of error, we're going to replace the field value with none, and we're going to put that error into that list. So that's quite straightforward to do. Let me paste that code here. Let me fix the indentation. So we have now another model validator, but this time the mode is after. And we are going to basically loop through the model fields. So we have now the instance of this Pydantic model. That's self. We loop through all the model fields, and then we get the value for that field. So we can use the getAttr on self, and then we have the field name. And then we check if the value is an instance of the error class. Well, we're going to append that error, right? That value, remember, is now an error. We're going to append that value to the errors list, and we're going to set the field to none. That's what the setAttr does here. And then we just return the model back once that's been done. So let's try the example again that we had. Let's see what we get. So now if we look at M, well, we can look at M. You can see that M has A, B, C, and D, where A equals 3, and then the other ones were set to none. There were errors before, there were error instances. Now they're just none. That's what happened here. We set the attribute to none when it was an error. But moreover, we now have something populated in that private variable. We have those errors that we collected, right, during the validation. So the only thing left maybe is to, instead of having this private field, right, private errors, we're going to make it public by using a computed field. So again, we're just going to, I'm just going to copy paste that from the notebook, but that's very straightforward. We now introduce a computed field, which is the property, and the property name is going to be called errors, and it's just going to return self._errors. That's it. Okay. So now, if we do this example again, and if we look at M, you'll see that we have A, B, C, D, and now errors shows up in the model representation because we used that computed field. So it is a field now in the Pydantic model. And we can look at m.errors specifically if we want. And then if you were to do a dump, of course, so we could say m.model dump JSON, let's do an indent equals 2, then, and let's actually print that. So you can see that this is how now this model serialized, right? We have A, B, C, D, and we have errors as well, which is exactly what the author wanted, because he has an errors column in his database, and he's gonna, which is gonna be a JSON, JSON binary in his case, and he's going to put that in that JSON column. So now when he's looking at the database, he can see, the fields that were validated okay. He can see fields that didn't validate, and he'll get an idea here of the errors. So this is a really, really neat approach of doing this. I thought it was really clever, and I really wanted to share it here in this channel, because this is something that I probably will get a lot of use as well. So thank you to the author for coming up with that solution, and I hope you guys find it useful. Thanks for watching.